Hello guys, welcome to the channel. In this particular video, we will be looking at the problem Subtree in N-ary Tree. Let's see what it says. Here is the problem. It says that given root of a N-ary tree, find the number of duplicate subtrees in the N-ary tree. Let me explain. First of all, we will talk about what is N-ary tree. So an N-ary tree is basically a tree which is having no restriction on the number of children. So if this is the root, then this root can have one children or two children or three children or four children or any number of children. Even for any node, we have multiple children possible. Okay, now it says that we are given the root of a binary tree, I mean root of an n-ary tree, and we have to find the number of duplicate subtree in the tree, right? Fine. And what is a subtree? A subtree is basically a tree which is contained by the whole tree itself, right? Like this is one of the possible subtree, and the subtree starting from these nodes will also be subtree, right? And it says that two trees are duplicate if they have the same structure with the same node values. Let me explain this as well. So if I have a tree like this one, I have these two trees, so I can call them duplicate. Why? Because these are having same node values and same structure. But let's say if I have a two trees like this, so you can see that these two have the same values but doesn't have the same structure, so these are not valid duplicate subtrees, right? Now I hope you have understood the concept. So let's talk about this example. For this example, you can see that there are multiple subtrees possible. Let me explain those, but first of all let me erase this thing. So subtrees which are possible are, first of all the leaves are a subtree. All the leaves are subtree. The second is this whole tree. If you notice here, these are the subtree. From each node we will be having one subtree which is starting from this two. We have this subtree, right? So these are the possible subtrees for this tree. Now as we need to count the duplicate subtrees, so just have a look at this 4 first. You can see that this 4 is a subtree and is repeating 3 times, so I can write 4 is repeating 3 times. Okay, and I'm drawing a square around this subtree, and this is the frequency. You can see that we have one more subtree which is this 5, and this 5 is again repeating 2 times, so I will write 5 repeating 2 times. And there is one more subtree. If you see this 3 5 and 3 5 here, so you will find that there is one more subtree which is 3 and 5, and this subtree is also repeating 2 times. So these are the subtrees which are repeating, right? So what I can do is I can store the frequency of every subtree, and when I do so, then I will have the frequency of all the subtrees. Like for this 2 4, for this 2 4, I will have the frequency as 1. And okay, I think it's not visible. 1 I have the frequency. And what about this subtree, which is 2 4 4 and then 3 and then 5? For this subtree, the frequency is again 1. This is occurring one time. And okay, so these are the subtrees that we have. And for this, okay, these are the subtrees that we have. And you can see that one thing, that if I count the frequency, then you will find that there are 3 subtrees which have frequency more than 1, right? So I can say that the number of duplicate subtrees is 3 here. 3. Now I hope you have understood the problem well. So let's talk about the solution. Okay, now here I have drawn the same tree which was given in the problem statement, right? Now for this tree, if you notice the problem statement explanation, then you will find that this is the point from where the intuition comes. I am storing the frequency of each element, like each possible subtree, right? And then I'm just iterating over all the, let's say this is a map, because a map is the data structure which will help in storing the key value pair. And this is something that I wanted, right? Fine. Now you can see that I'm just iterating over all the values of the map, and I'm just looking at whether the values are like duplicate or not. So if it is more than 1, in that case it is duplicate. So I can write the problem in some steps. The first step is store all subtrees store all subtrees uh, in a map along with frequency, right? This is the first step, frequency. Now the second step is just iterate over all the elements, iterate over map values map values, and then just check one condition. If my value, if my map value is greater than 1, in that case my answer is going to increase. So for this we need an answer variable which is going to be 0, and at last we just need to return answer, right? Now you can see that we can solve this problem in just 3 steps. Okay, so I think these 2 steps are very obvious and clear to you, like how we can just check all the map values. So this is something which differs for every language, because in C++ we have a map, and in Java we have hash map, and in Python we have a Python dictionary. So there are different ways to iterate, but what I'm interested in is explaining the concept of this particular part, the first step. This is really important. Even this is the question you are going to ask me, that hey, how to store all the subtrees in the map with frequency. So let me explain this. And to explain this, first of all, let me you can see that if we have a map, then in the map we are storing the subtrees and frequency like this, but there is no way to represent a subtree like this, right? So the optimal way that I can find is, let's say I have a tree, and the tree is represented as 4, and then I have 5, and then I have 7 here. Now for this tree I'm taking the example of binary tree because it is easier to explain. For this tree, how can I represent this tree? I can represent this tree as 4, after that the left children which is 5, and after that the right children which is 7, right? This is how I can represent this subtree. Fine. And what about, let's say I have, similarly if I have any tree, let's say I have 5, 7 and 9, so I can represent like 5, 7, 9, right? So this is how, and even I can call it a string value because string is easier to represent. Now again, one question, there is one question. Let me take an example. Let's say I have to represent 2, 11 and 1. This is the first, and the second is I have to represent 2, 1 and 11. How we will represent these two trees? For this tree, first I will write the root, then I will write the left child which is 11, and then I will write 1, right? For this, first I will write root 2, then I will write this 1, and then I will write this 11. But there is a problem here. You can see the problem, that these two values are like same, right? But these trees are not same. So how to handle this situation? You can see that like the problem may occur for situations like this. In order to handle this, we are gonna put a hash while like merging these values. Let me explain what I mean. For the representing this, first I will write root which is 2, then I will put a hash, then I will write this 11, then again I will put a hash, then I will write this one. This is how I can represent this subtree, right? Or this tree. And for this I can write 2, then hash, then 1, then again hash, then 11. So I can represent like this, and now again this is a string, right? So this means that I can represent any subtree with a string, and I think this concept should be clear to you. So what I'll do is, now I'm going to write one thing, that a subtree can be represented as a string, right? This is what we have figured out till now. Now let's see how we are going to iterate over all these subtrees. Like, we need to store all subtrees, right? So let's see how we can find all the subtrees in the form of string, of course. Now I'm going to write the same tree. Let's say I have 1, then I have 2, then I have again 2, then I have 3. After this I have 5, 4 here, 4 here, 5 here, then okay, 3 here, then 5 here, and then 4 here. This is a tree that even it is not looking so good and clear. So I think I need to copy this particular tree, right? I'm going to copy it. So I'm just going to, okay, let me select this again. After this I'm just going to copy it and I'll paste it here. Now I have this tree, and for this tree, let's see how we can find all the possible subtrees in the form of strings. So the idea is pretty simple. One thing that we know is, for this 4 and for this 4, for this, these are the leaf node, right? So if we have leaf node, then we can simply say that the subtree is the leaf node itself. Fine, right? So first of all, I'm going to, let's say I have a function which is solve, and it is going to take root as a parameter. So, and of course the return type should be string, because we want a string as the subtree in the form of string, right? Let's see how we can do it. First of all, notice here, when we have a leaf, then of course the root is going to be like the subtree is going to be root itself. So I'll write if leaf. In that case, just do one thing, that return like root value, right? Root value. But I want this value in the form of string, so I write something like this. Now you can see that this is going to give me all the root values. So let's say for this 4 I have the subtree as 4, so I will have 4 here, and I will have 4 for this, I have 4 for this, and I have 3 for this, right? Okay, so I will not come here, instead I will come this 5, so 5 for this. Now this 5 is for the subtree. I know for the left subtree I have the okay, so for the left node, I have the subtree as 5, right? So I'm just going to calculate the subtree as 3 hash, then put the left child, which is 5. So I'll put 5. So this is the answer for this 3. So I can write this. Even this 5 is going to pass. So I have got the answer for these two. For this, the answer is 3 hash 5. And for this, the answer is 3 hash 5. Fine. So till now I can write these values. I can write this value, that I have got 5 2 times till now, and 4 3 times, right? So I have got 5 2 times and 4 3 times, and I have got 3 hash 5 2 times again. Fine. Now I know that for this the answer is 4, for this the answer is 4, and for this the answer is 3 hash 5. So I can combine all these answer to form the answer for this particular thing. What does this mean? Let me explain this. For this particular 2, I can write the answer as 2. After this I will write a hash, and then I will write this 4, then again hash, then I will write this 4, then again hash, then I will write this 3 hash 5, right? 3 hash 5. This is going to be the answer for this 2. Now I have got the answer for this 2 as well, and for this 2 the answer is going to be 2 hash 4. So if I store these value in the map, because as this is a string and this is an integer, so the map will be a map of string and integer, right? So I can write this value as well. So I will write something like 2 hash 4, then hash 4, then I have hash, then 3 hash 5, right? And I have this tree occurring one time till now. What about this 2 hash 4? Let me store this as well. So I have 2 hash 4 one time now. And now as I have the answer for all these, so I can find the answer for this one as well. I just need to combine the answer for all. So I will write 1, then hash, then I will write 2 hash 4, then I will write the answer for this is something which was this one. So I will write 2 hash 4, then hash 4 hash 3, then hash 5, right? Now I have to write this answer as well. So I will put a hash again, and I will write 3 hash 5. This is how I can find the answer for each value. So what we have noticed till now, if you notice, then you will find that we can write one thing. Let me erase all these things. So this is how we can get the math. But for now, I'm just interested in explaining one important thing. And that thing is, we have figured out one thing, that for calculating the answer for any node, we just need to combine the answer for all the children's, right? So initially my answer will be let's say this is the return value. It will be initially be like this root, right? As I have one for this, and then I'm combining, so I will initialize with the root, which is the string, which is in the string form, right? Now I have the root. What I'm going to do is I'm just going to iterate over all the children's, and who remember one thing, guys, that this is not something which is a binary tree. This is an array tree, and this is something special about this question. As this is an array tree, so I need to traverse all the children, right? So I'm going to iterate over all the children's. I'll say for the children is node n as root dot children, right? Root dot children, something like this. So this is how I'm going to iterate over all the children, and once I'm iterating, so I will write my answer is going to be answer plus hash plus what is the answer for current children. How I will get the answer for current children, because this is what I need to append. So I'll simply write solve for n, and this is what I need to do, right? And after this I will have the answer, and I'm going to just return the answer. Return answer. Now see the beauty of recursion, guys. As this is a recursive call, so this is going to iteratively like recursively call for all the nodes, and then I will have the answer for all the nodes. This is the power of recursion. So now I can write the pseudocode. I can write the pseudocode. I have this function, right? I have this function. For this function, now the function return type is again string. So let me write the heading pseudocode first. This is the pseudocode. The pseudocode is pretty simple, that once I have this solve function, so I just need to check one thing, that if root is null, if root is null, right? I will write not root. In that case, return empty string. Fine. Now if root is leaf, if root is leaf, in that case, I just need to return root value, right? Root value, but I need to return this in a string format. Why? Because the return type is a string. Fine. Now for calculating the answer for rest of the values, I'll simply do one thing, that answer equal to root value string of. Okay, now interestingly, I don't need to check this condition as well, so I can erase this condition. I don't need to check this condition as well, because for root there will be no child, and then it will be automatically handled. Let me explain how. For every child, for every child, as the like leaf have no child, so it is not going there, it is just going to return this particular string itself. This is how it in this particular case, right? So for each child, what I'm going to do is I'm simply going to calculate my answer equal to answer plus hash plus solve then for child, right? Now when this loop completes, then I will have the answer. Then I will have the answer. Let me put it. Okay, now I can put it here, right? So once I have the answer, so this means that I have one of the possible subtree. So I need to store this subtree in the map. So I will write store. Okay, the spelling mistake here. So I'll write store in map. I'll write store answer in map. Right. Once I have stored the answer, I just need to return answer. Return answer, because when I say return answer, then this answer is going to give me the answer for this particular root, right? So this is how we are going to find all the subtrees. And once I have done this task, in after this I just need to iterate over all the map values. So let me show you the implementation. Here is the implementation in Java, and on the right hand side I have the implementation in C++ and Python. So you can see that for Java I have a function solve, right? And after this solve function, this solve function is same as the one I have explained you, but this is a map that I have made in Java hash map. And after that I'm iterating over all the values, and I'm just checking one condition: if value is greater than 1, in that case return answer. What about the C++ code? I have used unordered map, and for unordered map I have written the same function, which is my solve function, and I'm calling solve function, and then I'm again doing the same thing, right? And see the Python code here. Now there is one thing special. See the beauty of Python code. I have written a method inside a method. This is how Python works, right? And after that I have the same function, which is solve, and I'm going to here change all the I'm going to check all the values in the map, right? Now this is all about this problem. I hope you guys like the solution. Yesterday's problem is in the front of your screen, so this is all about this. Thank you.